Before we move on to the second type of van der Waals forces, I would like to ask you, if dipole-dipole forces exist between polar molecules, is there any intermolecular forces exist between nonpolar molecules? Nonpolar molecules has even distribution of electron, therefore there is no partial positive or partial negative end in nonpolar molecules. So, can nonpolar molecules attracted to each other? To answer this, let's learn about London forces or dispersion forces, which is the second type of van der Waals forces. Fritz London, a German-American physicist, first proposed the origin of this attraction in 1930. Basically, London forces exist in all atoms and molecules. If you look at the diagram, for a nonpolar molecule, the negative charge of the electrons in the atom or molecule is spread evenly around the nucleus. The diagram is showing one molecule is having an instantaneous dipole, which you can see that the molecule has developed two oppositely charges at both ends of the molecule. Remember, this instantaneous dipole can happen at any moment of time because electron is constantly moving in the atom or molecule. So, what happens if one of the nonpolar molecules is having an instantaneous dipole? When the molecules with instantaneous dipoles get closer to another nonpolar molecule, as shown in the second diagram, the molecule with instantaneous dipole will induce a dipole on the neighboring atom or molecule. Due to electron repulsion, an instantaneous dipole on one atom can induce a similar dipole on a neighboring atom, which can cause the neighboring atoms to be attracted to one another. So, as you can see in the diagram, the partial negative charge on the instantaneous dipole molecule is attracted to the partial positive charge on the induced dipole of the other molecule. These interactions is called the London forces or dispersion forces and only significant when atoms are very close to one another. Let's take a look at chlorine molecule as the example. Chlorine molecule is a nonpolar molecule. So as you can see, there are no charges appear at the end of the molecule. But at any moment of time, one of the chlorine molecule in the diagram might develop an instantaneous dipole due to the electron motion. Let's say the second chlorine molecule on the left is having an instantaneous dipole which will develop partial positive charge and partial negative charge at each end of the molecule. If the instantaneous dipole molecule gets closer to the third chlorine molecule, the third chlorine molecule will be induced to form a dipole with partial positive charge and partial negative charge at the end of the molecule. The partial negative charge on the instantaneous dipole molecule will be attracted to the partial positive charge on the induced dipole molecule. The attraction between the oppositely charged and between the molecule is called London forces. The same sequence of events may also occur to the first chlorine molecule if it gets closer to the instantaneous dipole molecule. The first molecule will be induced to form dipole or polar molecule, and the partial negative end of the induced dipole molecule will be attracted to the partial positive end of the instantaneous dipole molecule, forming a London forces. And eventually, all the chlorine molecules will be attracted to each other by London forces if they are closer to each other. Okay, now move on to the other example. State the types of intermolecular forces exist between each of the following molecules. In 4.2, you have learned on how to determine the polarity of a molecule. Okay, for the first example, Bf3 molecule. So, determine the polarity of the Bf3 molecule. Bf3 molecule is symmetrical in shape, which is it has the shape of trigonal planar, and all the terminal atoms of Bf3, which is fluorine, bears partial negative charge because fluorine is more electronegative than boron. Therefore, Bf3 is a non-polar molecule. As we have learned just now, a non-polar molecule will have London forces exist between its molecule. For the second example, CO2. Okay, let's take a look at the shape of CO2. CO2 has a symmetrical shape which is linear. The charge on the terminal atom, since both of the terminal atom is oxygen, so both oxygen bears partial negative charge since oxygen is more electronegative than carbon. So, symmetrical in shape, equal or the same charges appear on the terminal atom. So, CO2 is a non-polar molecule and London forces exist between non-polar molecule. For CHCl3, even it has tetrahedral shape or a symmetrical shape, but one of the terminal atom, which is hydrogen, does not have the same charge as the other terminal atom, which is chlorine. So CHCl3 molecule has uneven distribution of electron, making CHCl3 a polar molecule. Therefore, dipole-dipole forces exist among polar molecules. For CCl4 has symmetrical shape which is tetrahedral. All the terminal atom is the same atom which is chlorine. Therefore, all the terminal atom bears partial negative charge. So CCl4 has even distribution of electron and it becomes a non-polar molecule. The type of intermolecular forces that exist between non-polar molecules is London forces.